Hello friends, in this video we'll discuss about big data, what big data is and why do we need to use it. We'll try to use a real world example and try to understand when it becomes essential for us to use big data. Let's go ahead. Please read the sentence. If one person completes a task in 10 days, how many days will it take for 10 persons to complete the same task? Right? The answer is 1 because there are 10 people now working on the same problem, right? Trying to complete the same task. So obviously all of them will be able to complete the task in 1/10 of the time. This is the basis of big data. Okay. This is how Hadoop works. Let's go ahead. So I'll just give you another example that in Delhi's Ghazipur, there is a huge mountain of garbage, right? And every day a lot of people work in that garbage trying to recycle everything, right? What they do is they have trucks, they bring in those trucks and carry a chunk of the whole garbage. They take it to their processing plant, they process that garbage and extract and segregate items based on the type of that, right? So clothes, electronic chipboards, bottles, plastics, all those things are segregated and then those are recycled. So this is how the big task of recycling the huge amount of garbage is done, right? Through distributing it into multiple different plants. Now let's look at how much amount of data is being generated online. On YouTube every day 5 billion videos are played, right? And based on the user behavior they recommend you videos as well, right? So they are watching your own behavior and then recommending you new videos. How do they do it? This is through big data. On Twitter, there are almost 500 million tweets every day, 500 million tweets. How do they basically map all these things and show you relevant tweets that are important to you? Based on your behavior, right? Things that you like, things that you retweet. They record all these things and then start showing you similar tweets. On Facebook, 3.2 billion likes and comments are posted every day. And Facebook uses this data of what you like and what you comment to decide which post should come at the top of your feed, and it recommends only those kind of posts to you where you already have engaged previously. This is again done through big data. Without big data, it is not possible because all of these things are done through log processing. There are a lot of logs generated and Facebook, Google, YouTube, all these people process this data to make sense out of that. Your every action generates data on internet and this is transformed into user behavior for serving better ads and recommendations to you. So this is the essence of big data processing, right? I will give you another example of Nike. For example, Nike launches a new shoe model, right? After a month or two, it will go to Twitter and say that, okay, give me all the tweets that have mentioned this particular model or Nike, right? Then they have to, let's say for example, Twitter returns them 1 million tweets. So they have to go through 1 million tweets and do sentiment analysis on each of those tweets to figure out whether the tweets are positive about Nike or negative about their Nike, right, product. So this is where they need big data because it is not possible to process 1 million tweets serially. But for example, what if there were 1 million is 10 lakhs? What if there were 10,000 workers working on each of these on basically 100 chunks of these items, right? Then it will take just a few minutes, right, to process all this data and return, right? So these are the technologies in the big data field: Hadoop, Hive, Big, HDFS. So we'll discuss these 4 here in this video. So Apache, Spark, HBase. I will also discuss HBase by the way. Cassandra, Kafka, Splunk and Presto. These are some of the technologies that you should try to Google and learn as much as possible. Hadoop. What is Hadoop? Hadoop is a framework to store huge amount of data and process that data through parallel processing. So we have already understood what parallel processing is. But what is this distributed storage of data, right? For storage, they use HDFS. The storage component of Hadoop is called HDFS. And then for processing that data, MapReduce is used. Okay. So let's see what HDFS is. Let's say you have 10 terabyte of data. Can you store it on one machine? Right? It's not possible. Let's say you have a laptop which has a storage of only 1 TB, or let's say 512 GB. So you'll need 20 laptops like this to store that amount of data. So this is what HDFS does. It divides your data, right? If you have let's say 10 terabyte of data, it will divide it into 20 groups and store in all the different systems. But another problem is that what if one of those laptops crashes? Then you will not be able to retrieve that data. So what it does is it will have a 20, 40, 50 laptops, and it will divide those chunks and copy it in more than one machines. So each of those data will be copied on 3 machines. So even if one of those crashes, you will have that data on some other machine. But this is for redundancy. This is for to make sure that data is available all the time. And then this distribution is done through in a master slave model. So there is one machine which is a master, which takes care of distributing this. The logic of distributing your big data into small chunks is done by this master node, which is also called name node. Then the small laptops which are already there, right, or the small hard disk where all this data is stored, right, are called data nodes. These are called slaves also. So this is where your actual data resides, and this takes care of the logic behind distributing that data. So data is replicated in multiple servers to make sure that when one system crashes, you still have all the other data, right? So all these points have been written here. What is MapReduce? As we discussed earlier, that if there is a huge task and you allocate more than one people, if you allocate 10 people to do the same task, you will get the work done faster. This is exactly what MapReduce does. It divides that information, right? It divides that problem into smaller, into multiple people, and then then they send them to process that data, right, or do their work. When they are done with their work, they come back and say that okay, we have done the work, and then Hadoop knows that okay, the whole work has been done in just 1/10 of the time. So this is what Hadoop MapReduce does. It is the processing component of Apache Hadoop. It processes data parallel, so that now instead of one person working, there are 10 people working. Divides the problem into small chunks. Again, a portion of the huge task is given to one person, right? So if there is a wall which has to be created and it is of 10 meters length, so 1 meter is given to each of those. 1 meter is given to one person. The second person is given the second meter, right? From 0 to 1, 1 to 2, 1 to 2 to 3, 3 to 4. They will divide it into 10 parts and then allocate 1% to it. But instead of one person, right? So instead of doing the whole wall building by one person, it is done by multiple people. So 1/10 of the time is taken to multiple data nodes. Yeah. One other thing is that in case of this data, right, data will still be there on these data nodes. The data does not travel to any other machine and their processing is done. Your code, your logic is directly executed on these data nodes. So there is no data transfer cost. So data, let's say there is 1 TB of data here, it will not transfer to some other machine and there that processing will be done. In the traditional applications, this is how it works, right? You write a query, that query returns a data set, and then you do processing on that, and then you return it to the web view. But here the whole task is done on each of these small machines, so there are no data transfer costs. What is Hive? Another big doubt that people have is what is Hive? So when you want to extract data, you have to write specific logic for that, right? So for that, instead of, for example, in traditional database also, you have a table and you write SQL queries to access that data. Similar to that, in Hadoop, you can write similar SQL queries, which is syntactically also very similar to SQL, which is this Hive query language, which is called Hive query language, which is HQL mentioned here. It is very similar to SQL queries. So this query gets you that data from the Hadoop file system. Example is select star from employees limit 5, return only 5 employees from all the employees. So this is how it works. Now when you write these queries, this gets converted into MapReduce tasks, right? These whatever query you write, they get distributed into multiple systems, and then the information is returned, and then at the end you get the final result. So you write HQL queries that gets converted into MapReduce tasks, and then that MapReduce task processes that data, returns to the MapReduce machine, and then the data is returned to user. What is Apache Pig? this is also part of querying data. So this is also just like Hive, which is an SQL-like interface. This is a scripting language. The language is called Pig Latin. So it is very similar to what we have, how we write scripts. The task of both Hive and Pig is to extract data from the huge amount, extract useful data, useful meaningful data from the huge amount of data which is available. This is the syntax of a program written in Pig Latin to count the number of words in a huge database, right? Let's say that you have billions and billions of text, right, in your Hadoop file system. If you have to count the number of words, how many times each word comes on that, in that huge amount of data, this is how it works. So if somebody wanted to find out which words are used in Twitter till now and how many times each of those words were used, this is what they will write. So this is the syntax. It is more of it, instead of just one line of query, this is a set of instructions, a set of scripts. So this is what Pig Latin looks like. And earlier we have already seen that Hive query looks like this. There could be multiple complex versions of these as well. What is HBase? Now another component of Apache is Apache HBase. It is a NoSQL database on top of HDFS. Okay, is used to have random real-time read-write access to big data. So the data which is stored is generally for read purpose, but if you want to do it really fast, HBase is used because it is a NoSQL database which is generally very fast. Okay, and it has been modeled after Google's Bigtable. Google developed Bigtable and HBase is created similar to that. So this is what big data is all about. If you have any queries, please ask in the comment below and I'll try to answer that. And this is our platform called Amigos, which is a social network for college students. You can make new friends, you can connect with your college friends and find out about internships, events, scholarships, competitions and placement mock tests on that as well. Okay, so all the best. If you have any queries, feel free to ask me. Thanks a lot.